We are starting chapter 10 today. We're dealing with circles and circumference. If you would please, we're going to go ahead and zoom in right here on this circle. Thank you for not making ridiculous noises in my video. It would make me angry. You know who I'm talking to. All right. So, right now, in a circle, can somebody please read me raise your hand, read me the definition of a circle. Go ahead, Mr. Starks.
A circle consists of all points in the plane that are a given distance, called the radius from a given point.
So right here, this length is a radius. Notice, it's the same length all the way around. Now, what tool did we just use recently that helps us draw circles? That's right, a compass, that's right. So, from a given center point, right here, center point F, if I were to go all the way to where D is, and then go all the way around, from that center point, that's how a circle is created.
I wish we could move our focus to that accurately.
You've seen me do it.
Not like that.
No, not like that. Not like that. Okay. All right. So, by the way, what do we call a segment that goes across? Yeah, that's a chord. So right here. So right there, from A to E, that's called a chord. It goes all the way across. Would you agree from D all the way to B is another chord? It's just a special type of chord. What do we call a chord that goes actually through the center of the circle?
Radius.
Oh, all the way across.
Oh, diameter.
Diameter. There we go. Okay. So right here, if we were to take a look at this, it says, name the circle. How do you name a circle? You name the circle from its centermost point. So this circle would be called circle F. What's this circle going to be called? Circle L. Now sometimes you can do a really cool draw a little circle with a little tiny point right there in the middle and call it circle L. That's going to be your answer for number one. That's the name of the circle.
If we got out, we have to start with a little circle.
Yeah, so just focus on, by the way, that's how you name it. Circle L. So you draw a little circle with a dot in the middle, call it circle L. Then it says name a radius. Now, it says name a radius. We're going to name all the radii. By the way, radii is the plural of radius, okay? So go ahead, give me one.
LT.
L to T. By the way, I not only like how you said that, it's correct. I like how you said it because you went from the center out. Now, there's another reason why I like LT.
LR.
Why do I like LT? That's right, because LaDainian Tomlinson is the San Diego Chargers. All right, so that's why I like LT. Also, I know Lawrence Taylor was an awesome football player as well, but I like LaDainian Tomlinson. If you don't know who LaDainian Tomlinson is, then you should Google it, watch some highlights, and you'll be amazed and saddened that you didn't realize who he was in the first place. Now, what's another one? Somebody said L to R. All right, LR. Good job.
LW.
LW. Good. So those are all three radii that have been drawn in the circle. Very good. Now the next one, it says name how many chords? 2. Now a chord, by the way, you could actually name 3 chords. But go and give me one of them, Mr. Starks. Go give me a chord. Give me a chord over here. If you're not sure, that's okay. Oh, go ahead, Jared. R to what? R to T. You're right. That technically is a chord. That's a chord. That's a chord that also happens to be the diameter. Go ahead.
RS.
RS is true. RS is totally a chord. By the way, I know we've already named 2, but you know what? We like to be extraordinary, not just ordinary. Go ahead. S to T is correct.
Yeah, so let's say 2.
All right. Now, there are technically 3 chords. We've named 3, but you know, we just named 2. It says name a diameter. Now, there's only one diameter here. Go ahead. No. LT is just a radius. A chord has to go from one part of the circle to the other part of the circle. The only reason that R to T is a chord is because it goes from one side all the way through another. It just happens to pass through the center. So a chord that passes through the center. See, a chord that contains the circle's center, that's what we call a diameter. So that's why the diameter is from R to T. Now, this one, number 5, it says, name, that's a good question. Name a radius not drawn. radius that's not drawn as a part of the diameter? Go ahead.
WL.
WL, yeah, that's true, but I prefer LW. I prefer LW. From the center to the out. But technically, you're right. WL, that distance is the radius. And that's it. Those are the first 5 problems, right? So let's go ahead and look at the next problem. I'm going to zoom in. Real quick, okay? So, Alex, could you give me some information that could help us with this problem? It's on your paper. I had to zoom in so we could look at it. So give me some information like, I think this would be useful. Go ahead.
You have 2 circles.
2 circles.
1 L, 1 L.
Okay, 1 L. Okay, so we have circle L, right? Circle L. And we have circle M. Good. Keep talking.
You also have
Look at your
1
paper.
line.
Good. So look at your paper. Look at the information.
Oh. The diameter of L and M are 20 and 13 respectively.
Ooh. So diameter of L and M are 20. Oh, let's do 20. 20 and 13 respectively. So in order. Okay. Good. Anything else? Anything else?
And find each measure and QR equals 4.
Oh, thank goodness. QR is equal to the number 4. So here's what I want you guys to do. Right where it has Q and R, I would like you to put the number 4 right there in the distance between Q and R on your paper. The next thing I want you to do, all right, is we are going to go from, I'm going to change colors here, all right? For L, circle L, I'm going to go all the way across right there in red. And for M, I'm going to go all the way across in green. Okay. Now, changing colors to red. If the diameter is 20 in L, what is the length of this radius right here? 10. Okay. So something that you guys need to know: the radius in your journal, if you write the radius is always 2 times the diameter, or you could say, I'm sorry, I apologize. My apologies. The diameter is 2 times the radius. The radius is always half the diameter. All right, there we go. So D is always equal to 2R, and R is always equal to half of D. So it's okay to make a mistake as long as you correct yourself before
You make it cool.
Yeah, it's okay. Nobody watches these videos. Well, okay. Well, you know what? Then somebody watches them. Because you're not a no You're somebody.
I'm worried about that.
So, the diameter is always twice your radius. The radius is always half your diameter. So we know that this distance from here to right there is also a 10. Now I'm really excited because that should help us find the distance from L, bless you, to Q. So what would this distance be right in there? That's right.
Oh, yeah, okay. So you use 4
You see, that distance right here, that's got to be a what? That's got to be a 6. And of course it's not working, but that's okay.
So now we just put
6. LQ equals 6. All right. Now, what is the diameter of circle M? It's 13. So what's this distance right there? 6.5. You're right. Which means this distance right, come on, you stupid boy. Right there. That distance is also a 6.5. Ooh. So what would this distance, if that distance is 4, what is this distance right there? That's right. It's got to be 2.5. Because 2.5 plus 4 is what? That's right. So if this is 4, that has to be 2.5. So what is the distance from R to M or M to R? Have to be 2.5. Now, understand, that was really helpful. Knowing that QR was equal to 4, that kind of helped us out quite a bit. So those are those 2 answers. Okay. Now we get to talk about the concept of a circle. All right. So here's what I want you guys to understand. I'm going to draw a circle. So if you would, just do your best. Just kind of draw a circle. It doesn't have to be perfect. Okay. All right. I'm going to to put a point right here, though. Put a point right there.
All the way on paper or on your?
No, in your journal. In your journal. And right there, from the center of that point, I'm going to stretch this out. I'm going to do one circle right there. So I'm going to call this circle C. You know what? Just so you guys aren't confused, I'm going to call it circle. All right. Now, C is called the circumference. You're trying to find the distance around the circle. Okay? So the circumference is basically, all you got to write down is that's going to be the distance. Okay? Also known as the length, right? The length around the circle. And you guys already know that. You guys should have been taught that many, many, many years ago. You know what the circumference is, okay? Now, if you take the circumference, the capital C, and you divide it by the length of its diameter, so we put D equals diameter. I'm going to draw in the diameter. So that's the diameter all the way across. The chord that goes all the way across. It's all highlighted. So if you take the circumference and you divide it by the diameter, you get an exact number. But it's an exact number that's never been totally found to be exact. Yeah. So the exact, we call it pi, right? All right? But you guys pretty much know pi as an approximate value of what? 3.14. Now, the fraction that best represents pi, which is not equal to pi, but best represents it, the fraction that best represents it is 22 over 7. Now, 22 over 7 is considered to be a rational number because it's a ratio of two integers, okay? All right? So how close is this to the actual? We go to the calculator, check it out. If I type in pi, which is the second in the caret button right here, you guys see the number 3.1415? If you do 22 divided by 7, you guys see how it gets relatively close, but it's not perfect. All right? What would this round to right here? This would be a what? 3.142, and this is 3.143. So it's pretty close. It's not the same. Everybody, this is considered to be a rational number, but pi is considered to be an irrational number. It's probably the most famous irrational number. It's a number that cannot be put in the form of a fraction. It just goes on and on and on and on and on, and the pattern doesn't repeat. So there's no repeating pattern. This has a repeating pattern. It's 22 over 7. All right. The pattern of 1, 7. In case you're wondering, the pattern of 1, 7. That's going 1, 4, 2, 8, 5, 7, and then it repeats. 1, 4, 2, 8, 5, 7. It just keeps repeating that. So that's a pattern. It doesn't look like there's a pattern there, but there is. Okay. Pi does not have that same pattern, so it's considered to be an irrational number. But what you need to know is the circumference divided by the diameter is always equal to pi. Okay, so if you want to know what pi is equal to, that's what you do. Take circumference divided by the diameter. Now, other formulas you need to know. Circumference by itself is either equal to pi times the diameter, or you could say it's equal to 2 times pi times the radius. Now, you need this formula. You need this formula. They get you the same result. Okay? It's either, remember, because what did I tell you the diameter was equal to? The diameter is always equal to 2 times the radius. That's why it's 2 pi r. Now, if I wanted to solve for the diameter is going to equal the circumference divided by pi. So if you want to figure out the diameter of a circle, take the circumference divided by pi. If you want to find the length of the radius, the length of the radius is going, remember, this is also equal to the circumference. The length of the radius is going to be the circumference divided by, not pi, but divided by 2 times pi. I'm going to put that in parentheses because sometimes students forget to use parentheses when they use this one. This is a much easier formula to use. So the circumference is equal to pi times the diameter, or 2 pi r. The diameter is equal to the circumference divided by pi. And the radius is equal to the circumference divided by the product of 2 times pi. So you need to have all those formulas down. So if you need to find the diameter, use this. If you need to find the radius, use this. Or you can do the diameter, and then whatever answer you get, just divide by 2. So let's look at some of our problems. Here we go. Let's see here. We're going to do problem number 8. And we'll do problem number 9. Now, everybody, very important that you follow these instructions. I asked you to round things to the nearest hundredth, which is the second decimal place. So please do that. Now, number 8 is pretty easy. If the radius is 7.5, what's going to be the length of the diameter? Yeah, 15. So just put 15. That was easy. Now, find the circumference. The circumference is equal to pi times the diameter. So you can just take pi and multiply it by 15. Now, the exact answer, everybody, the exact answer in terms of pi would be 15 pi millimeters. But I told you in this one to round to the what? Nearest hundred. So I do want you to know sometimes, what am I going to ask you for? I'm going to ask you for the exact answer in terms of pi. So this would be the exact answer in terms of pi. All right, so if I ask you for that, that's what I'm looking for. But this one, I'm actually looking for the approximate answer. So all you have to do in the calculator is type in 15, hit the pi button, and you get 47.12. 47.12. That is your circumference. So just go back, type in 47.12 millimeters. Notice, why did I not round? Because it was not a 5 or higher. It was just a 3. Okay? So we don't round it up. If it was a 4, you'd still keep it 47.12. If this was a 5, then it would be 47.12. Well, I'm just answering the question that you're given. Okay? Now, moving over to number 9. Number 9 is a little bit trickier. What were we given? We were given the circumference. What is the formula for the diameter? What did I tell you guys? The diameter is always equal to C divided by pi. That's right. Circumference divided by pi. So what are you going to do in the calculator? You take 227.6 and you're going to divide it by pi. That's what you're going to do. You're going to find an approximate answer. 227.6 divided by pi. So here we go. 227.6 divided by pi. Now what does that give you? That gives you the what?
72.44.
Oh, very close. We're going to call it 72.45 because that's a 7. So we have to do what with that 4? We have to round it higher. Okay, so we go back. 72.45. And yes, please put YD for yards. And that's what you're going to put right here. 72.45 and put yards. Give your measurement a unit of measurement. Now what am I going to do in the calculator now? I'm going to take that number and divide it by what? Divide that by
2 pi.
No.
Oh,
just 2.
Oh, yeah.
And you should get 36.22. 36.22. Now what does that mean? That means that's the length of my radius. You put yards. Now let me explain to you what students will do where they'll make a mistake. Watch this, all right? If you take 227.6 and you divide that, and I open up a parentheses and put 2 pi, you'll notice you get the exact same answer as we just did, right? But look what happens if you don't use the parentheses. Look what happens. Hopefully a lesson will be learned. Some of you will learn this lesson. Some of you will not. Hopefully you'll be one of the students that learns it. Watch what happens when I do this. Because the calculator knows order of operation even if you don't. This is 227.6 divided by 2 times pi. So what's my suggestion? Divide it by pi, then divide it by 2. Divide it by pi to get your what? Divide it by pi to get your diameter. Then divide your answer by 2 to get your radius. Okay? Or what would you have to do? Use parentheses. Now I know some of you out there are like, well, just use the alpha y equals button, you idiot. Well, you could do that too. And then you can do 2 pi without parentheses. This is the only time you can do it without parentheses to be able to get that number right there. Okay? So if you don't like parentheses, then you better use alpha y equals enter to get
Or you can just do
what we just did. Okay? That's what you're doing today. Good luck.